Question 1. In the context of radon mitigation for a mixed foundation home, a contractor encounters a section with slab on grade adjacent to a basement. The sub-slab depressurization fan is already installed, but the basement FE readings are low. What should the contractor consider to achieve compliance with HEPA standards? A. Install an additional suction point in the basement slab. B. Increase fan motor speed beyond rated capacity. C. Add exterior wall vents for passive airflow. D. Seal basement floor drains permanently. Answer. Correct answer. A. Explanation. Adding an additional suction point in the basement slab improves pressure field extension by targeting zones with insufficient depressurization, aligning with EPIUST mitigation design guidelines. Increasing fan speed beyond rated capacity risks overheating and motor failure, violating manufacturer specs. Exterior wall vents may disrupt system balance and draw in soil gases. Permanently sealing floor drains can cause code violations and lead to moisture issues without guaranteed radon reduction. Question 2. When analyzing radon entry in a structure with high water table levels, which mitigation design consideration is most critical for ensuring consistent system performance? A. Incorporating a moisture bypass channel into the SSD piping. B. Selecting a high-volume, low-pressure radon fan. C. Installing the vent pipe inside the conditioned space. D. Using perforated suction pits to increase surface draw. Answer. Correct answer. D. Explanation. Perforated suction pits expand the surface area for sub-slab depressurization, ensuring better draw in wet soils where permeability is reduced. Moisture bypass channels are not a recognized standard practice for SSD. High-volume, low-pressure fans may not overcome water saturation resistance. Placing vent piping inside conditioned space helps thermal lift but does not directly solve low permeability challenges. Question 3. Given the circumstances, Maria, an HVACR radon mitigation specialist, is troubleshooting a system with a manometer reading that fluctuates widely daily. The system uses an exterior-mounted fan. Which factor should she address first? A. Inspect for partial blockages in the vent discharge. B. Relocate the fan to the attic for temperature stability. C. Replace the manometer with a digital pressure sensor. D. Seal the exhaust outlet to prevent backdraft. Answer. Correct answer. A. Explanation. Fluctuating manometer readings often indicate variable airflow caused by partial obstructions like ice debris or nests in the discharge. Addressing this restores consistent negative pressure. Relocating the fan to the attic may help temperature consistency but does not resolve existing blockage. Replacing the manometer changes measurement tools but not performance. Sealing the exhaust outlet would violate ventilation principles and create backpressure. Question 4. Through the lens of building science, how might HVAC system operation unintentionally increase radon entry rates in a home? B. Creating a positive pressure in the basement during heating cycles. B. Using supply-only ventilation that increases indoor pressure. C. Producing negative pressure in lower levels during system operation. D. Maintaining constant neutral pressure throughout the structure. Answer. Correct answer. C. Explanation. HVAC systems can create negative pressure in lower levels, drawing soil gases, including radon, through entry points. Positive pressure in the basement typically resists infiltration. Supply-only ventilation raises indoor pressure, which can help reduce entry, not increase it. Neutral pressure balance does not favor soil gas intrusion, so it's not a contributing factor to increased radon levels. Question 5. Based on the information, a radon mitigation system in a crawlspace uses a polyethylene membrane sealed at edges. The client reports reduced radon, but high humidity persists. What should the specialist recommend? They add a dedicated crawlspace dehumidifier. B. Replace the membrane with thicker plastic. C. Switch to a passive submembrane system. D. Remove membrane edges for ventilation. Answer. Correct answer. A. Explanation. While the membrane controls radon entry, it does not address pre-existing or ongoing moisture. Adding a dehumidifier targets the humidity source directly. Thicker plastic doesn't significantly change humidity control. Passive systems are less effective than active, especially for both radon and humidity. Removing membrane edges would allow radon infiltration, undermining system purpose. Question 6. With respect to radon fan selection for a high permeability gravel subslab foundation, what is the optimal design approach? A. Select a high pressure low flow fan. B. Choose a low pressure high flow fan. C. Use multiple high pressure fans in parallel. D. Install no fan and rely on natural stack effect. Answer. Correct answer. B. Explanation. High permeability gravel allows airflow easily, so a low pressure, high flow fan moves large volumes of air efficiently without excessive static pressure. High pressure fans are unnecessary and waste energy in permeable substrates. Multiple high pressure fans increase costs without benefit. Passive stack effect is less reliable, especially for consistent mitigation per EPA standards. Question 7. In light of recent developments, Jacob is performing post-mitigation testing and finds radon levels have dropped significantly but not below the EPA action level. Which step aligns best with us guidance? A. Replace the fan with a higher capacity unit. B. Conduct feed testing to identify weak zones. C. Add window fans for temporary ventilation. D. Extend the vent pipe above the roof ridge. Answer. Correct answer. B. Explanation. Feed testing identifies where the mitigation system is failing to reach target pressure fields, guiding targeted improvements. Simply replacing the fan may not solve distribution issues. Window fans are temporary and unreliable. Vent pipe extension improves discharge dispersion but not subslab depressurization coverage. Question 8. Throughout the course of SSD installation in a basement with radiant floor heating, what precaution must be prioritized? A. Avoid drilling near embedded heating tubes. B. Place suction points under the heating manifold. C. Use metal vent piping exclusively. D. Install fan at floor level for better suction. Answer. Correct answer. A. Explanation. Drilling near embedded heating tubes risks leaks, costly repairs and system shutdown. Suction points under manifolds can interfere with heating performance. Metal vent piping is not mandatory and may not offer benefits over PVC and radon systems. Fans should be located per manufacturer guidance, typically outside conditioned space, not at floor level. Question 9. Considering the evidence, why might sealing foundation cracks alone be an ineffective primary mitigation strategy? A. Radon can diffuse directly through concrete surfaces. B. Sealants degrade quickly under soil gas pressure. C. Sealing increases pressure differentials in the soil. D. Radon originates only from water sources. Answer. Correct answer. A. Explanation. Radon gas can diffuse through intact concrete, making sealing alone insufficient. Sealants may degrade, but the main limitation is radon's ability to pass through porous materials. Pressure changes in the soil factor in movement, but not caused solely by sealing. Radon can originate from soil and water, so claiming only water sources is false. Question 10. From a practical standpoint, during mitigation system placement, which routing consideration best meets both performance and aesthetics? A. Run vent piping through closets to the attic. B. Use shortest possible route with minimal bends. C. Conceal vent piping within an exterior wall cavity. D. Route piping alongside HVAC ducts for uniformity. Answer. Correct answer. B. Explanation. Short, straight vent piping minimizes resistance, enhancing fan performance per EPUS design principles. Routing through closets may be discreet but can lengthen the path and increase resistance. Concealing in wall cavities can be costly and difficult to maintain. Placing pipes alongside HVAC ducts is visually consistent but often suboptimal for airflow efficiency. Question 11. While examining a radon mitigation system in a home with a finished basement, Alex notices the fan is running continuously but basement radon levels remain above EPA action levels. Which step is most appropriate to troubleshoot this scenario? A. Inspect for blockages in suction pit connections. B. Increase fan size without evaluating system layout. C. Remove basement floor coverings to increase suction. D. Add exterior passive vents near foundation walls. Answer. Correct answer. A. Explanation. Continuous fan operation within effective radon reduction usually indicates flow restrictions. Inspecting suction pit connections for blockages ensures the pressure field is properly distributed. Increasing fan size without diagnostics may not address the root cause and can waste energy. Removing floor coverings is destructive and unnecessary if flow is blocked elsewhere. Adding passive vents may interfere with negative pressure, reducing system efficiency. Question 12. To illustrate this point, a radon specialist is designing a sub-slab depressurization system for a home built on clay soil. What is the most effective design adjustment for low permeability soil? A. Increase the number of suction points under the slab. B. Use a smaller diameter vent pipe to raise velocity. C. Install the fan in the attic rather than outside. D. Rely solely on natural stack effect for mitigation. Answer. Correct answer, C. Explanation. Locating the fan in the attic helps avoid freezing and improves system reliability, but does not solve low permeability alone. The key is ensuring suction points reach all sub-slab zones. Increasing suction points is standard, but must be combined with proper fan placement. Smaller diameter pipes increase static pressure unnecessarily in low permeability soil. Relying solely on stack effect is unreliable for radon reduction. Question 13. As demonstrated by recent field measurements, Samantha observes a crawl space with high radon levels even after membrane installation. Which approach best ensures mitigation compliance? A. Add an active submembrane fan to create negative pressure. B. Replace membrane with thicker polyethylene. C. Install additional vents to allow passive airflow. D. Spray sealant along the foundation walls. Answer. Correct answer, B. Explanation. Thicker polyethylene increases structural durability and reduces potential microleaks, improving radon control. Adding a fan actively depressurizes the submembrane, but in some low permeability crawl spaces, membrane integrity is a bigger factor. Additional vents may inadvertently draw radon into conditioned space. Sealant along walls can help, but it is supplementary and cannot replace proper membrane integrity for effective mitigation. Question 14. In an effort to integrate HVAC operations with radon mitigation, a technician notices the basement is under negative pressure whenever the furnace runs. Which corrective measure aligns with best practices? A. Install a make-up air system to balance basement pressure. B. Increase furnace blower speed to push more air down. C. Seal all basement windows permanently. D. Relocate radon fan closer to the furnace duct. Answer. Correct answer, A. Explanation. Negative pressure caused by HVAC operation can draw radon into the basement. Installing a make-up air system introduces controlled fresh air to offset negative pressure while maintaining mitigation efficiency. Increasing furnace speed can exacerbate negative pressure. Sealing windows alone does not address airflow imbalances. Relocating the radon fan near the furnace does not solve pressure dynamics and may compromise the system. Question 15. Considering the evidence, a newly installed SSD system shows strong pressure at suction points but low readings at the furthest edge of a basement slab. Which is the most effective next step? A. Add an additional suction point near the weak zone. B. Replace the fan with a larger capacity unit immediately. C. Seal floor cracks throughout the slab first. D. Reduce the vent pipe length to improve suction. Answer. Correct answer, A. Explanation. Pressure field extension testing identifies areas where suction does not adequately depressurize the slab. Adding a suction point in the weak zone effectively extends the pressure field. Simply replacing the fan may not reach distant areas. Sealing cracks is supplemental and does not generate the negative pressure needed. Shortening vent pipe may improve airflow slightly but is insufficient to address far edge pressure deficiencies. Question 16. The fundamental question is, why might a radon mitigation system in a high-rise building require multiple sub-slab suction points instead of a single central suction? Yea, high-rise floor slabs are extensive, preventing uniform pressure distribution. B. Multiple fans increase the building's structural stability. C. Single suction points reduce radon decay efficiency. D. Multiple suction points minimize noise complaints from occupants. Answer. Correct answer, A. Explanation. Larger or segmented slabs in high-rise buildings limit the reach of a single suction point, making multiple suction points necessary to create an effective negative pressure field across the entire slab. Multiple fans are rarely required solely for structural reasons. Radon decay is unaffected by suction points. Noise considerations may affect fan selection, but not the need for multiple suction points. Question 17. Through careful analysis of radon in well water, a technician finds elevated levels in a private home. Which mitigation approach is most effective? A. Install granular activated carbon or aeration treatment systems. B. Vent the water line directly into the basement. C. Increase sub-slab depressurization to capture waterborne radon. D. Use a membrane over the foundation to block soil radon. Answer. Correct answer. D. Explanation. Membranes and SSD addressed soil radon, not waterborne radon. For elevated radon in well water, aeration systems or granular activated carbon fills safely remove radon before entering the home, effectively preventing inhalation. Venting water into the basement introduces radon into the living space. Subslab depressurization does not mitigate radon in water. Question 18. Given the circumstances, a technician is evaluating a passive SSD system in a home with mixed foundation types. Which factor most limits its effectiveness? A. Lack of fan to enhance negative pressure. B. Excessive vent pipe length. C. Using PVC instead of metal piping. D. Installation in a slab-on-grade section only. Answer. Correct answer. C. Explanation. Passive SSD relies on natural stack effect, so fan absence is expected. PVC is the standard material. A using metal does not inherently improve passive performance. Limited installation in slab-on-grade areas can reduce effectiveness, but only where sub-slab access exists. Excessive pipe length slightly increases resistance, but is less critical than foundation coverage. Question 19. From a practical standpoint, while performing post-mitigation testing, Michael notices diurnal variations in radon levels. Which explanation aligns with building science principles? A. Indoor-outdoor temperature differences drive stack effect, altering airflow and radon entry. B. Fan failure occurs randomly due to voltage fluctuations. C. Sealant off-gassing temporarily increases radon production. D. Piping material reacts with soil gases under sunlight. Answer. Correct answer. B. Explanation. Diurnal radon variations often result from temperature-driven stack effect and HVAC cycling. Random fan failures due to voltage fluctuations are less common but possible in inconsistent power conditions. Sealant off-gassing does not generate radon. Piping material does not chemically produce radon. Soil origin is primary. Understanding airflow, pressure, and building envelope interactions is crucial. Question 20. By evaluating radon mitigation system aesthetics, a homeowner requests minimal visual impact while maintaining performance. What is the most appropriate design compromise? A. Route vent pipes along exterior walls with minimal bends, painted to match siding. B. Conceal all piping within interior walls even if it increases length. C. Reduce fan size to allow hidden attic installation regardless of flow. D. Increase the number of suction points to minimize visible venting. Answer. Correct answer. B. Explanation. Concealing piping within walls can improve aesthetics, but must consider flow resistance and fan capacity. Routing along exterior walls with paint blending maintains efficiency but is more visible. Reducing fan size risks underperformance. Increasing suction points for visual reasons may compromise design simplicity and increase maintenance complexity. The goal is performance first, aesthetics second. Question 21. In terms of foundation sealing, a technician discovers multiple hairline cracks in a basement slab. Which approach best aligns with effective radon mitigation practices? A. Seal the cracks with appropriate caulking before SSD system operation. B. Ignore minor cracks since SSD fan alone will mitigate radon. C. Fill cracks with expanding foam and paint over them. D. Seal only the visible cracks on the perimeter walls. Answer. Correct answer. A. Explanation. Properly sealing hairline cracks ensures that negative pressure from the SSD system is effectively maintained and that soil gas infiltration is minimized. Ignoring cracks risks air bypass paths, reducing mitigation efficiency. Expanding foam can block airflow but may degrade over time or react with concrete, causing failure. Sealing only perimeter walls leaves central cracks unaddressed, compromising the pressure field and system performance. Question 22. Considering the evidence, a radon professional is evaluating vent pipe routing for a multi-story building. What is the most effective design principle for balancing performance and code compliance? A. Minimize bends and maintain continuous upward flow with exterior discharge above roofline. B. Route pipes internally through closets to avoid exterior exposure. C. Increase pipe diameter arbitrarily to reduce noise. D. Run venting horizontally under the slab for efficiency. Answer. Correct answer. C. Explanation. Increasing pipe diameter arbitrarily does not enhance system performance and can reduce velocity, potentially compromising radon transport. Effective design requires minimal bends, continuous upward flow, and proper exterior termination above roofline. Internal routing through closets may increase pipe length and resistance. Horizontal subslab piping does not promote stack effect and risks trapping radon in. Question 23. From the perspective of diagnostic techniques, a manometer reading indicates inconsistent pressure at multiple suction points, which is the most systematic approach to identify the issue. A. Conduct a sequential suction point isolation test to identify underperforming zones. B. Replace the fan with a higher capacity unit immediately. C. Increase vent pipe diameter to stabilize readings. D. Seal floor cracks to improve pressure readings. Answer. Correct answer. A. Explanation. Sequential suction point testing isolates underperforming areas, allowing targeted remediation consistent with US diagnostic best practices. Replacing the fan or increasing pipe diameter may not address the root cause and can be wasteful. Sealing cracks can supplement but does not reveal specific pressure field deficiencies. Systematic testing ensures effective co-compliant solutions without unnecessary modifications. Question 24. While it is true the crawl space radon mitigation can use a passive system, the homeowner reports radon spikes during high humidity periods. What is the most effective mitigation adjustment? A. Install an active submembrane fan to maintain negative pressure regardless of humidity. B. Increase membrane thickness. C. Remove insulation to allow passive airflow. D. Add a small vent to outside for humidity relief. Answer. Correct answer. B. Explanation. Thicker membranes reduce microleaks and resist deformation under varying humidity, maintaining integrity for passive mitigation. Active fans are highly effective but may not be needed if the primary issue is membrane integrity. Removing insulation may increase heat loss and not directly address radon. Adding vents may compromise negative pressure or allow unfiltered air, reducing system performance. Question 25. From a practical standpoint, a mitigation system installed on a slab-on-grade house shows high radon levels near a rear extension addition. What is the optimal design adjustment? A. Add a suction point under the slab of the new addition. B. Replace the fan with a higher capacity unit to cover the extension. C. Increase vent pipe height above roof line. D. Seal cracks in the original slab only. Answer. Correct answer. A. Explanation. Extending the system to cover new construction ensures the pressure field includes the addition. Replacing the fan may not address localized pressure deficiencies. Vent pipe height affects discharge dispersion but not slab depressurization. Sealing only the original slab leaves the addition unprotected, allowing radon entry and violating HEPA mitigation standards. Question 26. The correlation between HVAC operation and radon entry is observed in a split-level home where the lower level becomes negative relative to the upper floors during heating. What is the recommended approach? A. Introduce control make-up air to balance pressure and reduce radon influx. B. Close all supply vents to the upper floors. C. Increase furnace fan speed to force air downwards. D. Seal basement doors permanently. Answer. Correct answer. D. Explanation. Sealing basement doors can reduce airflow-induced pressure differentials, minimizing radon drawing. Controlled makeup air is generally preferable for maintaining system balance, but sealing is simpler first corrective measure in specific cases. Closing up of vents or increasing furnace speed can worsen negative pressure. Balancing pressure through proper HVAC and sealing strategy ensures safe radon mitigation while protecting indoor air quality. Question 27. As a result of post-mitigation testing, radon levels drop significantly after fan installation but fluctuate seasonally. What diagnostic approach best explains the variation? Evaluate stack effect and HVAC-induced pressure differences that alter radon infiltration. B. Replace the fan with a higher powered model. C. Seal all remaining foundation cracks regardless of location. D. Install additional suction points randomly throughout the slab. Answer. Correct answer, B. Explanation. Fan replacement alone is unlikely to explain seasonal variations. If fluctuations are typically caused by temperature-driven stack effect, pressure changes from HVAC operation, and soil moisture conditions, randomly adding suction points or sealing indiscriminately does not provide targeted mitigation. Understanding airflow dynamics and pressure relationships allows professionals to identify and correct seasonal performance issues efficiently. Question 20. Given the circumstances, a high radon reading is detected in a home with a private well. Which mitigation strategy best addresses the source? A. Install granular activated carbon or aeration treatment on the water supply. B. Increase SSD fan speed to capture radon from water. C. Seal floor cracks to prevent radon entry. D. Vent radon-laden water into the crawl space. Answer. Correct answer, C. Explanation. Radon in water requires treatment at the source through aeration or carbon filtration. SSD fans and crack sealing address soil gas, not waterborne radon. Venting water indoors is unsafe and increases exposure risk. Proper water treatment protects indoor air quality by removing radon before household use, aligning with EPA guidelines for radon and water mitigation. Question 29. Through the lens of system labeling and documentation, why is accurate record-keeping critical for radon mitigation systems? A. Ensures future maintenance, regulatory compliance, and homeowner understanding. B. Serves primarily for insurance claim purposes. C. Allows the fan manufacturer to track product usage. D. Prevents the need for post-installation testing. Answer. Correct answer, D. Explanation. Record-keeping supports maintenance, troubleshooting, and compliance with EPA protocols, ensuring that future technicians understand system layout and performance. While insurance or manufacturer tracking may benefit their secondary, accurate documentation does not replace post-mitigation testing, which remains critical to confirm radon reduction effectiveness. Question 30. Taking into account soil and foundation characteristics, why might a slab-on-grade home with sandy soil require fewer suction points than a home with clay soil? A. Sandy soil is highly permeable, allowing air to move easily under the slab. B. Clay soil naturally blocks radon entry, reducing suction needs. C. SSD fans perform more efficiently on clay due to higher resistance. D. Slab-on-grade construction always requires fewer points regardless of soil. Answer. Correct answer, A. Explanation. Highly permeable sandy soils allow subslab air to flow freely, enabling fewer suction points to create an effective negative pressure field. Clay restricts airflow, requiring additional points to achieve full depressurization. SSD fan efficiency is affected by soil resistance. A high resistance increases workload. Slab-on-grade does not universally determine suction needs. Soil permeability and foundation design dictate system layout.